This is Unit 2, Section 2, and we are on our 4th day of Chapter 4. Here we're going to be graphing functions using technology. So you're going to want to open Desmos.com, and we're going to be dealing with some numbers that are not as nice. All right? So the first thing we're going to do is we're going to graph this equation. We're going to scale the graph so that we can see all of the relative maxima and minima, and then we'll identify the key features that are asked for. So we have our function here. So I'm going to minimize this, and I'll minimize this so we can see both. Okay, so we're going to want to graph this entire equation. So we're going to type that in. So we have negative 5x to the 4th minus 82x to the 3rd plus 180x squared plus 215x plus 1,265. So you notice on this now, let's move this over, that all we see is one line. And if I zoom out, now I see a second line. And I'm going to have to keep going out and zooming out really far because I need to see something really high. And I keep zooming, and I can see now my red stops here. So my red is going to stop a little bit below 70,000. This is really skinny though because I have my axes at the same rate. So what I'm going to do is I'm going to go to this graph settings, and I'm going to change my x-axis to be from negative 20 to 5. Negative 20 to start, positive 5 to end. If I had zoomed in a little closer at the bottom, I would have seen that where my two numbers were, and that's why I chose negative 20 and 5, because now I could see that full 70,000, right? I could see everything I need to. So I could start to answer some questions right away before I even get to any more things we can do within Desmos. So my domain, let's go over here. My domain, since the arrows went down in both directions, which really meant they went fully to the left and fully to the right in both directions, we're going from negative infinity to positive infinity. My range, though, I notice I do have a highest point. So the lowest point would be negative infinity. But the highest point, I'm actually going to click on the graph, and just clicking on it, I'll see a gray dot here. So that dot tells me the y value, that's the highest y value of the graph. So that's 66,852.213. 852.213. And that's included, right? It's not open there. So I'm going to use that square bracket. While I see all these other dots here, I can also find the y-intercept. Right? I also should have known the y-intercept because it was written in standard form. So my y-intercept was 0, 1,265. My x-intercepts, I see that I have a dot over here at 3.482. And I also have a dot over here at negative 18.282. Then for relative maxima and minima, it's really hard to see because it's very close here, but my graph goes down slightly before coming back up. So the lowest point here, relative minima, is at negative 0.459, 1,211.945. And then it goes slightly up before going back down right here. So that would be 1.727, 1706.315. All right, so we use our technology that's available to us, and it'll tell us all the features we need to know, right? It shows us the little dots everywhere there's something important happening. If we were using a graphing calculator, there are things we can do. Basically, what we would have to do is we'd know that it happened somewhere in this area, so we would start looking over here at -15 and end looking at the -10, and know that somewhere between them we should be hitting our maximum. All right, so there are ways we could do this on a graphing calculator. It's just a little easier in Desmos. All right, so you're going to go ahead and try the next one. All right, graph this equation, scale it so that you could see everything that's important happening. This one's going to be a little trickier because it's an odd function, so the arrows will be going in both directions, so it's going to be a little harder to see how high you should really be going, but you're really looking for where it changes. So as long as we could see the places it changes, we're okay. All right, so pause, give that a try, and I'll show the answer. Okay, go ahead and check your answers. All right, if it helps you to have it on your page, you could always do a rough sketch, and you know that it's going to look something like this. And you can even label what those points were, right? They don't have to be exactly to scale on your graph, but you can label where the y-intercept happened, where the x-intercepts happened, and so on. So now you're going to see the real reason we're talking about this is because we can have these equations represent actual things in the real world. And usually when things represent numbers in the real world, they don't come out to be very nice, because that's just the way the world works, right? So here we have, during a 10-year period, the amount in millions of dollars of athletic equipment E sold domestically can be modeled by this equation, where T is in years. So we're going to use our graphing calculator to identify and interpret the following. So we'll focus on identifying first, and then we'll really talk about what that means. So I'm going to graph my equation. And I'm going to still use x instead of t when I graph it. It's not going to make a difference if I chose to use t. All right, notice I can't see it at all right now. Zooming out, and I see a bunch of my changes here. So I'm probably going to want to see up to at least 26,000. So I'm going to make my x's go from -10 to 20. And my y's from -10 to about 26,000. All right, and once I have that, I can zoom a little bit so I could see more of what I wanted to see. But again, you see the picture of what I'm looking at. So domain looks like it would be all real numbers, but think of what they said in the problem. During a 10-year period. So all we care about for the domain is from 0 to 10. And we'll interpret it afterwards. So what I'm going to do here is I'm going to add the fact that I'm only going up to x equals 10 so I could see what the y value was there. I only care about the graph from x equals 0 to x equals 10. I only care about it between these two numbers. Okay? So we have our point there, point there, point there, point there. All right, so we have all the points we need. So the range, the lowest value I see for the y values is this one here, the 21532.399, and the highest value I see is here. So my range is really between those two numbers. So that was 21532.399 to 25270.641. My y-intercept was at 0, 21614. The relative maxima was at 7.802, 25270.641, and the relative minima was here. I put 598, 21532.399. So now let's talk about the interpretation. The domain from 0 to 10 means we're only looking at years 0 to 10. Let's go in a different color for the rest of these. The range, what this means is they earned, or sold, I should say, they sold anywhere from, right, this is in millions of dollars, right, 21,532.399 million to 25,270.641 million. The y-intercept means at year 0, they sold 21,614 million. The relative maxima was in year 7.802. They sold the most at 25,270.641 million. And the relative minima means in year 0.598, they sold the least at 21,532.399 million. So all we're doing is we're giving what these points represent in the context of the problem. Okay? So you're going to try this last one. It's going to be a much nicer picture. All right, they're not giving you a starting or end point, but you'll see what the starting and end point should be on the graph. So go ahead and try this one, pause it, and I'll show the answer. All right, so that's our answer. And that's the end of this lesson.